All right, hello everyone. I am Professor Caudill, and I know where we ended last time on 61. I guess we can take another look at it. I did fix the calculator. So these two dictionary entries were swapped. So that's why it was giving me a wrong answer, but now it gives me 90, which seems to agree with the chatbot. Um, so yeah, if you are using this, you will select your function. F3, this matches up with these. Okay, so if I want to use F5, I put in F5. 0 is your V, squared is V, so it'll be 0 squared. A, if you don't know A, or if you don't know V, you just put V for A. X or X naught. So this is your 2, it's just left to right. The variables are just left to right. This is X naught, and then this is V naught. So in this calculates 90 uh, meters per second squared. So let's say we know acceleration is 4, but we don't want to know v. Then it's going to give us two answers, and we're going to have to pick which one makes the most sense. Okay, so I guess we'll just move on. I guess we'll go to 62. It's so unwary football player collides with the particle, so he runs into the wall. Okay, collides with it. So V naught is 7.5, and V is 0 because it's a full stop. I guess X is 0.35 meters. X naught is 0. Okay, so here we're solving for A, and then we're gonna use that to solve for T. Okay, so before we begin, before we put in the calculator, we want to verify first our units are right. And second, that it makes sense. Like, should 7.5 be negative? Those are the questions we want to ask. So he's running into the goalpost. 7.5 should be positive, I would say. Um, Distance is positive. All right, so I think we're good to calculate this. So obviously we're going to use equation 4. We know x is 0.35. Okay, we know a is a. Sorry, I kind of blanked there. All right, so we don't have time, so we can't use this. So my bad. We're actually going to do equation 5. So we're going to do 7.5 for the final. No, we're going to do 0 for the final velocity. A, x is 0.35. X naught is 0. V naught is 7.5. Okay, so we're getting negative 80. And obviously that's meters per second squared. Let me double check. Yes, they're all in meters. Okay. So now we're gonna use this. Um, yes, I did want to make something that was like F6. Find F6. BV. So it's going to be similar to this, except acceleration is that. Okay, so we know so X is 0.35. Acceleration is this. T is T, that's what we're solving for. V naught 7.5 and then 0. Okay, so we're plugging it into equation 4. Okay. And I can just rename it. Answer is that. If I'm using F6. Maybe I shouldn't. Using F5. All right, so F6, F6. All right, so this will be XX, TT, BV. Answer invalid. Need a colon. Answer invalid. Syntax. Okay. A is not defined. Answer. A is not defined. T, A, no. All right. I think we're just trying to do too much, so we're just gonna scrap it. Scrap it, and maybe it'll make sense to us another day. All right, so T, so we're gonna change this to F4. 0.35. A is negative 80.35. Okay, T is what we're solving for. V naught 7.5. X naught was 0, so our answer is a tenth of a second. A tenth of a second. So does it make sense? So it's running. How long does the collision last? Tenth of a second. See about right. Bang. 1/1000. 1/1000. It's short. It's 1/10 of that. Uh, okay. Let's move on. 63. Care package dropped out of a cargo plane. Lands in the forest. Assume the care package speed on impact. So V is 54. Solving for A. B, okay, let's say negative 54. And V, okay, so V naught, Y naught is 0. Okay. Okay, so it's not giving us time, it's just giving us the velocity. Dropped out of a cargo plane, lands on the ground. 0, 0, 5.8. 54. Okay, so assume the tree and snow. That's our key information. Assume the trees and snow stops it over a distance. Stops it over a distance of 3 meters. So y is 3. Okay, so it's like, are we using gravity or not? It's like it's asking us to find for A. So, I mean, we're going to use equation 5. So, V is 54. That's final velocity. Solving for A, we know y, y is 3, x naught is 0, v naught 0. Okay, 486 meters per second squared. So I'm gonna plug this in to the chatbot because kind of, I mean, that's very fast. All this. Okay, that's what we did. That's what we did. Negative 406. Why are they getting negative 54? Okay, saying v, the final velocity is really 0. So this is 54. So that would mean we're going to swap these. This is 0. This is negative 54. So do we understand why that is? So, yeah. Chiropractic speed of impact is 54 meters. Okay, yes, makes sense. So V naught is 0. Its original velocity is 54. Okay, so our calculator's working. The calculator works. It's just the hard part is picking out what the variables from the English. It's extracting. So let's see. Difficulty is in extracting variable quantities from English. Okay, 64. Express train passes through a station. Train station. Initial, okay, easy. Accelerates opposite. So A is negative 1.5. So X is 210. Solving for V. Okay, and then we're solving for T, given that And train is 130 meters long. End of the train, so it's going to be 340. That would be the end of the train. So they want to know B given that. Okay. When does the end? So then they want the T given V given X. Okay, so we have a lot to do here. First, we're going to check our units. Looks like it's all in meters and seconds. Check the signs. Acceleration is a negative. Variables are good. X is 210. X not 0. I don't think I need to write that though. Alright, so we're going to do F5. We're solving for V. A is negative 0.15. X 210. X not 0. V not 22. So we're going to get, I think it will be 20.5. So passing through it, as it goes through, it slows down ever so slightly over 210 meters. Okay. Does that seem right? It's like it barely slows down at all. Okay, well I guess we'll just do it and then we'll get a second opinion. So now we need to use that to find T. How long does that take? So we're going to do X, it's 210, negative 0.5, solving for T. V naught is 22, X naught is 210. And V should be 20.5. That's X, my bad. 210, we're using equation 4 now. So I guess we're not using 20.5. We don't need that, I don't think. 210, V naught's 22. Or maybe I want this to be 20.5. because it's going to be when it passes. It's like the end V becomes the new V. Does that make sense? All right, so I'm guessing it's 273 seconds. Okay, now they want the velocity. Or solve for V. And 273 seconds. X 340. 0. V naught is 20.5. Okay, so that should be 17.8. Then take this. Now we know V, so do 340. Solving for T. V naught is now going to be that number. X naught is 340. So 237. Okay, so now we can ask, do these numbers make sense? So how fast is it going when the nose leaves the station? So it's going 20.5 meters per second. How long is the nose of the train in the station? 273 seconds. It's quite a long time. I guess it makes sense. And then now we're going to calculate it at the end. So I added 130 and 210. So what is the velocity of the end as the train leaves? So when it leaves the train, velocity is 17.8 meters per second. Okay, so you can see it enters the train station after 210, and then by the time it leaves, it's a lot slower. And the end leaves after 237 seconds. So we have a problem because this is saying the nose of train okay, so we want to know, when does it end? When does the end of the train leave this train station? So we're going to take the nose is in for this. So I'm thinking question D is going to be 273 minus 237.9. And I'm going to add that to 273. Okay, so 273. So after 308 seconds, the end of the train should leave the station. So that's a lot to put together. You can get a second opinion. Okay, so V is this. So let's just check mark what we get right. Okay. T is 10 seconds. So what happened here? Okay. So here it's saying 10 seconds. Okay. Train is going at a rate. Okay, so we got the negative that right. Now it's using a completely different equation. No. What equation is this? 1/2. 1/2. So it's using equation 4. Okay, so V is U plus AT. U is fun. U is initial velocity. So it's using equation 3. So it's saying A is using F3, B it's using F4. Okay, C do it all. So you see how like I just gave it basically the same information and it gives me a different answer. 22.5. 210 over 22. 210 over 22. 210 over 22. Okay, so okay, I think maybe I'm seeing it. We're using equation 4, equation 3. Okay, so what might have we done? So we might have used displacement instead because we could have found this. So let's try that. So all right, so we're gonna do F1 is V average. V is 20.5. V naught is 22. Okay, so 1/2 T F1. Solve equation 2, solve equation 1. Okay, I'm gonna fix that. I'm gonna have to re-upload that to the GitHub. Okay, so saying is V is 21.25. Okay. Now we're gonna plug that in equation 2. X is 210. Solving for T. 21.25 T X naught. Zero. Okay, so I'm saying this is 9.8 seconds. So we really used F5 and F3. We did F5 into F3. It's one. No, F2. So we used F5 into F1 into F2. Okay, so I think that's what we did. Found V, given 5, plugged in V into F1, got average velocity, plugged average velocity into F2, got T, okay. Okay, so now we can probably find this with F4. So now we're gonna do F4, X210, T, okay, V naught is 22, X naught is 0, answer is 0, so we need to solve for something. So what are we solving for? X, okay, so we're gonna say 210 was X naught, we do 340, 3. Okay. 340. Um, 550 seconds. Doesn't seem right. Let's try 130. 40 seconds. Doesn't seem right either. 210 minus 130. 80. Okay, so what did that do? Okay, so language models is pointless. It language model, as we can see, it can't differentiate the beginning and end of a train because these are literally the same questions. These are different questions. It's using the same numbers. So the language model just fails here. Uh, aren't. All right, so it's still giving us 9.5 seconds. We're just gonna move on. I think my intuition was right in the beginning, but it's like I don't want to spend too much time on it, so I'm gonna move on. 65. I think 64 was like a good. Uh, it was like I think we got out of it a lot, even if we didn't get everything right. And it's also important, even if like we're not getting the answer right, if we're actually noticing that language model is getting it wrong, then it's like we're kind of half right because um, we're not correct enough to get it ourselves, but we're correct enough to notice a chatbot is getting it wrong. So I would say that's better than being completely wrong. So uh, I think that's the most value that the language model offers, just another perspective. Sometimes it's wrong, sometimes it's right. It really just comes down to critical thinking and unreasonable results. So Drexers. Okay, finding average acceleration. Okay, so it's going to be V over T. I mean, wouldn't that just be average velocity though? I guess acceleration could be constant. I mean, you could have 32.6. If you integrate that, then you get 32.6 T V. Okay, so if T point is, then you get 145. So nothing wrong with a constant acceleration. It's just, it's like, do I add it now? It's like, now that I have it, do I add it? Uh, I guess I could just add a note instead of rewriting the whole thing. Average acceleration v must be not. Okay. So now here's where the language model gets dangerous because it kind of just pointed me in a direction, and I really am not sure. I mean, it makes sense, but it's like um, I'm giving a lot of weight to the language model here, so hopefully it doesn't screw us. But all right, 32.6. Okay, that's what we calculated. Find the final velocity. Okay, so if it's at rest, v naught is 0. Okay. Find the final velocity of this dragster starting from rest. Okay, so should be easy. Find the final velocity. So we're going to do v is going to be a is 32.6, x is 402, 0, 0. Okay, let me check my units. Okay, so if we're plotting a, it's going to be, it's going to accelerate. So it's going to rise quickly. And then it's going to reach a limit. Okay. So the velocity is going to slowly pick up. So this is a big number. I think we would take this divided by what would we do if we did this? Thousand. Yeah, this is just such a big number. So do we do anything wrong? 32.6, 402. X naught, V naught is 0. So it's gonna be 64 times 402 square root. So I'm thinking this 32.6 might be wrong. So let's see what the language model says. Okay, 32. Okay, we get a big number. Hmm. Why? Why is this so big? 2 million. V A X X naught V naught. Equation 5. V squared. V naught squared. Okay, let me just check. Okay. One 61. Okay, I see. We didn't change it to F5. There we go. Man, 161. So why is the final velocity greater than I used to find? Okay, makes sense. Um, it's like I'm thinking if I could have a function where I choose like 5 and then it prompt user to enter variables in a text box. Help me write this new equation, this new function that lets me choose one of these. Oh, that's a lot. Okay, so we want to I'm gonna take this out probably. Let's say we wanted to do let me write this down. F5 B 32.6 40200. So I want to do function 5 velocities V construct string to float. I need a function 5 final velocity V 32.6 40200. Oh, that's nice. That that is beautiful. So we can close this. All right. Say I want to do function 1 velocity v average convert string to float. Likewise, We're about out of time. Okay, so but like this is beyond, this code is beyond me. B, okay, we're gonna do equation one. B average final velocity, let's say 5 meters per second, and we start at 1 meter per second. So we get 3. Okay, let's try again. I want to do equation 3. Final velocity is 10 meters per second. Acceleration is 5 meters per second. Time is t. I'm going to solve for t. V naught is 0. So we get t is 2. Okay. Let's try equation 4. Displacement. We're going to do x. Let's solve for x. So we're on 50 meters per second squared for 30 seconds, starting at 20 meters per second, starting at 10 meters. So we're going to go this distance, okay? And 5. Final velocity, 50. We're going to solve for A. Let's go 500. And start at 100. 20. A is 2.6 meters per second squared. So this is beautiful. I might add acceleration. All right, so yeah, I'll publish this and I'll see you guys next time.